All right, guys. Thank you for having us. We are BioMappers, or actually, we are part of BioMappers. The other guys are down there. We have just to frame the challenge. It's a tool for intelligent biodiversity analysis. What we wanted to do, we wanted to use and leverage public data to be able to maybe actually go to the next slide. It makes sense. So here we have Jens. Jens is a biologist, and he's hired to report on biodiversity for ATP Real Estate company located in Copenhagen. So that was what we wanted to do, but go to the next slide. Yes, just to frame it a bit about what ATP wants. ATP is a real estate that needs to comply with the Corporate Sustainability Reporting Directive. And it's called CSRD. The European Union has established biodiversity commitments for 2030. Monitoring protected areas is one of them. So, Jens, if you go to the next slide, is very excited to examine his area of interest. But before he goes and see what's there and check if there's any insects or if what kind of plants there is there, he would like to know more about the area. This area is down in Hvidovre, Copenhagen. So if you go to the next slide again. Yeah, as I said, he wants to know something about the area of interest. And okay, but anyway, our solution then will solve this problem for Jens, because Jens he can just look into our solution. So here's a quick quick demo of our point cloud, which we try to we'll tell more about this, but just to show what Jens could use from our solution. If you go to the next slide again, then you can show the demo, and then we will explain more about the process about this whole thing.
That what we showed just here, that is something that we made in Blender during the hackathon, but it's a bit difficult to demo here because it takes many minutes to compute. So what we also made is a really simple front end and back end, everything locally here. So basically you put in the coordinates here of the area of interest, and now we have put in exactly the same. You press on calculate. And now it fetches different data sources in order to calculate some KPI and give some simple information about the biodiversity in that area. So the first image we have, we fetch it from Dataforsyningen. It's like a near-red infrared image of that area. So because plants, they emit near infrared, so we can detect where there is vegetation and where not. We can also here calculate the coverage. And then we also have the point cloud. Here it's implemented in Plotly and React. So you can actually, it's the same scene as above there. So you can see grass is green, trees are dark green, and roofs are in red. It's a bit difficult to see because we have to sample so that it's reactive enough. And we are also estimating the biomass from the difference between the terrain height and the, what was the name of the other?
We'll get to that. We'll get to the process of the whole data.
Yeah. So this is the very short demo, and then we will continue here with the presentation. This is my slide. Actually, the user defines an area of interest as a polygon. We use this digital surface model and digital terrain model to estimate the biomass, which is basically the difference between these two. We take the RGB and near-infrared images to estimate the area that's covered by vegetation. We also use dimensionality reduction here, principal component analysis for those interested in machine learning. And then we visualize it as a point cloud. And we also have ideas for the future here that are not part of the demo. Yeah, this is basically what we went through already. So it's both in near infrared and in a normal color space here. We use principal component analysis to find the vegetation. We have this very difficult computation here, DSM minus DTM, to estimate the biomass. And this is yours.
So, as Bertrand said, we have some different outputs. For Jens, again, to come back to him, he would use the GIS map for the overview of the area and for understanding connections in the given site or given cadastre that he's using. He's trying to discover or register for ATP. As we also talked about with the KPIs, the bio KPIs he can get from the different data sources that Bertrand just ran through. And then, of course, he can visualize the given site in a point cloud, with the point cloud, and this gives him a good impression of the site beforehand he goes out. And we would also like to mention for future work that what we looked into was to incorporate ADA-Deco or GBIF's API. So Jens would be he would be able to understand the species around there in the given area, and would be able to implement that as another KPI. And of course, we could also use the point cloud to visualize the tree, as you can see, and use them. The tree base from Copenhagen Municipality, there's a species list of all trees, so we could compare those and train a machine learning model to actually recognize which kind of tree is there in whatever area of interest the user would know something about beforehand they go out. Yeah. Then.
We do have a public GitHub account with MIT license, so it's called ASE Biodiversity, so you can go in there and check. And we also have a selfie of the team, so it's Lauritz and me, Bertrand, and then there is Eigil, Paul, Franz Xaver, and Dan in that corner there. A bit scared to come up here. Yeah, thanks a lot for listening.
Can I start out? Thanks for a great presentation. You mentioned Jens and ATP. Can you elaborate a bit on the end user?
Yes. So Jens, who's a biologist, could be one end user. He's hired. I guess Jens is working in a consulting engineering company where he's hired to actually do this kind of research in the field for ATP, which wants to comply with the CSRD. But Jens just needs information about what he's going out to, and he can spare a lot of time. Oh, sorry, he can save a lot of time using our product. It could also be gardeners or other maintenance workers that would actually be interested in using these kind of maps for whatever maintenance they would actually do in the outdoor facilities. Yeah.
Okay, maybe kind of following up on that. You said saves a lot of time. How much actually Jens can save time? And then you were looking at kind of two KPIs, vegetation coverage and biomass. Would there be something more detailed information you could include on your service in the future that would save even more time for Jens?
Yes, Jens knows all about these data sources, but the problem is that he would do a lot of analysis beforehand. So we are just helping him. I can't say exactly minutes. I guess it's maybe hours actually for Jens. And in order to answer your other question about other analysis or other KPIs, you could look at matureness of trees. Which also is a KPI that you could actually say something about, or state something about biodiversity. There is a lot of indexes or indicators that you can actually discover here. That's also why we mentioned species, fauna, which we think is very interesting.
Hi, super cool. I just want to challenge you a little bit on the ambition side of things. You're focusing a lot on Jens. But in the storyline that you showed me, I saw ATP there. So, who are you solving a problem for? You're solving a problem for Jens, or you're solving a problem for ATP? Could you direct your problem towards ATP instead of Jens? That's kind of more on a business perspective. I really would encourage you to adopt other use cases. I become more curious also what's under the ground. So principally, I've seen some other texts where they roll out over and they also map what's under the ground, which is also a huge problem for real estate developers, where you actually have the value chain starting out. So definitely, some focus on the other use cases. And then a question on the tech side, large language models. So mapping the vegetation, the view that you get with the fauna, could we even spare Jens for going out there?
With respect to the large language models or the fauna, the data we have seen, that's already categorized, so I don't see the benefit of using a large language model, because the data has a given model in a way, and it's much easier to just use the exact same model. Then for the use case, maybe you want to say something?
Yeah. I mean, Jens, in the future, our hope is that Jens would only sit at his desk and work from there, because then he would save even more time. But what he would need there is probably some IoT sensors or stuff like that that would actually register some kind of fauna, because of course you can get a long way with only plants in a matter of biodiversity, but scientists would definitely claim that it's not enough for saying something about such a complex field. Yeah.
Just
We
a
can-
brief question.
Okay, just one more addition. Maybe not large language models, but we did some investigations with convolutional neural networks and autoencoders on if we could categorize the plants from the 3D mapping a bit better, which we think would be doable, but unfortunately was not in the short time frame.
Yeah, exactly. That was the scenario I was thinking of.
Yeah,
at least.
yeah. So we think there is a lot to do with machine learning, but maybe not large language models.
Yeah.
Just a brief question. Towards the end, you say that you can develop further, and then you start getting a grasp of the diversity, you can say, towards the end. How far from the idea you have now until you could finish that? I mean, are you ready? Could it be done? Is it a lot of work and years of work, or do you have the data available?
I think my impression was there's quite a lot of data available in Denmark, and specifically the city of Copenhagen, which has really a lot of high quality data sets that we could use. So I think until there's working prototypes, like really shitty prototype, but you could measure it in weeks probably. But then of course, if the data quality gets worse, this is when the real work starts.
It also depends on what you're aiming for. If you're just aiming for the screening, as we was, I think you, as Bertrand says, you will be finished in 1 or 2 weeks maybe for a prototype. But if you actually are aiming for describing biodiversity, which is a very, very complex field or very, very complex topic, then I would say you cannot finish this in maybe 1 or 2 months, 3 months maybe. But it also depends on which level of scientific approach you want to actually take. Yeah.
Yes. Thanks.
Yeah, just I don't know if I mentioned it, but we did, all the data is on GitHub, and we did put an MIT license, so everybody is free to take the data and contribute or fork it and start your own project based on that. So we would be very welcome.
Thank you, team.
Okay.